This question is about circuits, and it says in the circuit shown the power supply is a fixed voltage V. That's an important starting point, and the resistor is a fixed value R, and again that's important to note. The two bulbs are identical. When the switch is open, just bulb X is lit, and when the switch is closed, both X and Y are lit. And it says state and explain whether the brightness of bulb X will increase, decrease, or stay the same when you change the switch from open to closed. So if we look at this part of the circuit, this voltage gets shared across R and across X. When the switch is open, the circuit's a little bit simpler. And this voltage, the current that flows, is due to this voltage and how much resistance there is to current. So the current is given by the voltage divided by the resistance, and the resistance is the total resistance of these two parts of the circuit. If we then close the switch, then actually what happens to this part of the circuit is, rather than just having one bulb in series with the resistor, we've got two bulbs in parallel with each other and in series with the resistor. And having these two choices of routes means that the resistance of this part of the circuit is actually less. And for two identical bulbs in parallel, or two identical resistors in parallel with the same, the resistance actually halves. So we get less resistance from this part of the circuit. So closing the switch reduces the resistance of the overall circuit. And that's key for us to be able to answer this question. So the resistance of the bulbs combined is less when that switch closes. So then what effect does that have on the rest of the circuit? Well, I've just said that the current is the voltage divided by the resistance. And if the resistance of this part of the circuit falls, then the total resistance of the circuit also falls. So closing the switch will increase the current in the circuit overall. So the current in the circuit is increased overall. Now that has an effect on what's happening in this resistor. So if I go through my solution to this, when the switch is closed, the overall resistance of the circuit falls. Therefore, more current is drawn from the supply, and I'm referring to this voltage source as our supply. So more current is in the resistor R. So it's got no choice of route, so there must be more current in this resistor. If there's more current in this resistor, then this resistor gets a bigger share of the voltage. And you can use V equals IR to show that. So more current in the resistor R, therefore a greater potential difference drops in the resistor. The bulbs get a smaller share of the voltage. So the two bulbs, because R has taken a greater share, there's less left for the two bulbs. Therefore, if the resistance stays the same and the voltage is lower, then the current in X is less, therefore it's dimmer. If you look at the power of that, then having a lower voltage and a lower current will mean that the bulb is dimmer.